Hello, Algebra 1 students. Mr. Ford here. It is Thursday, April 7th, and today we're looking at the homework guide for 522, problems 65 through 70. We've already done A and B in class today, so all those answers are right there. But let's go ahead and talk about what's going on in this problem. What we're doing here is looking at the idea that this is a sequence of numbers. If you plug in the numbers 1, 2, 3, 4, 5, and so on into the function, it will give you the first, second, third, fourth, fifth term of the sequence. So for example, this sequence is 2, 7, 12, 17, 22, 27, and so on. The question is, will that sequence contain the number 447? Is 447 a term of the sequence below? And if so, which term is it? This is actually a really easy question to answer because what it comes down to is if you take the actual formula, 5n minus 3, and make it equal 447, what you're answering is the question, is this a whole number or not? If it's a whole number, then it's yes. And the whole number that it is the number of the term. So in this case, it's the 90th term. Over here, it's a decimal. It does not shake out to be a whole number, so it's not. Let's look at part C. So all we really need to do is take the equation part and write it again and make it equal 447, like that. You have a lot of choices on how you want to solve a problem like this. You could distribute the 3 and combine lunch-alike terms, but I think it's better to pick this one apart step by step. Let's start by adding 6 to both sides. And that'll cancel out the 6 on the left and leave you with 3 times n minus 1 equals 453 after you do that in addition. And then we'll divide the 3 out of there. 3 divided by 3 is 1, so it cancels out. N minus 1 is equal to, oh boy, calculator cam, hello, welcome, how are you? 453 divided by 3 is equal to 151, nice. And then if you add 1 to both sides, you will get the final answer of 152. So the translation here is that yes, 447 is the 152nd term. Over here in D, again, the question is 14 minus 3n equal to 447? We're going to subtract 14 from both sides. We'll get negative 3n equals 433. I think I'm doing that math right. Yeah, okay. And then, of course, we'll divide by negative 3 and see if we get a whole number. That's the question. Is it a whole number or not? 433 divided by negative 3. It's not. It's negative 144.3 repeating. So because we got a decimal, the answer here is going to be a no on that one. And question E, negative 8 minus 7 times n minus 1. Does that equal 447? That's the question. There will be an answer for this, but the real challenge here is it a whole number or not? 447 plus 8 is going to be 455. I don't know if 455 divides evenly by 7. Let's find out. I guess it's negative 7 technically. I'm going to write my next step up here. 455 divided by negative 7 is going to be, oh, look at that, negative 65. It totally is. And if you add 1 to both sides, you'll get n equals negative 64. So it is a part of the sequence, and it's the negative 64th term, which I suppose is to say that it's the 64th term back in time from the first term. 566, choose one of the sequences in 565 which you determine that 447 is not a term, and write a clear explanation determining how you can be sure that 447 is not a term of the sequence. This one, I'm going to leave this one up to you. I know I don't do this a lot in the answer guides, but I'm going to ask you to choose one of the two sequences that doesn't work. It's either B or D. Explain how you know that 447 will never be a term in that sequence. 567. Find the sequence generator for each sequence listed below and write an equation for the nth term in each sequence below, keeping in mind that the first term is 1, t of 1. Sequence generator, by the way, just means what's the pattern. We're going to find the pattern. Let's do that. And then we'll worry about the equation. So the pattern is easy. In this case, it's plus 3, plus 3, plus 3. That's it. Now, if you want to write an equation, you got kind of two ways to do this. I'm going to show you two ways right now. The first way is the way that I think is the simplest, but it's not necessarily the most obvious. So what you do is take your first term, which is 4, first term, oops, highlighter, and you're going to add to that the common difference of 3. But you're going to multiply it by, in parentheses, I'm going to put a parenthesis on it and do n minus 1 in parentheses, like that. This will always work for arithmetic sequences. You need the n minus 1 because if you plug in 1, you want to get 4 out. So in this case, if you plug in 1, you get 4 times 3 times 0, which is just 4, and that's the key. Now, the other way to do this is what we did back in chapter 2. You go back in time one step and land at 1. That's your 0th term. There. So the other way to write this would be to take your 0 term of 1 plus 3n. There you go. It's probably a good thing to point out that you can actually get, if you actually did the distribution of the 3 right there and did the math combining like terms, you would get 1 plus 3n. So these are actually the same equation. For question B, we're going up by, it looks like 5 each time, plus 5 plus 5. So one way to do it would be to take the first term of 3 and add 5 times n minus 1. That is the first way to do it. Or you can go back in time to the 0th term and do negative 2 plus 5n. Both of those will work really nicely for this. Question C, this is actually going down by 5, subtracting 5, subtracting 5. There you go. So the first way to do this would be take your first term, 24, and subtract 5 times n minus 1. That's the first way to do it. Or you can go back in time one step to 29. Add 5, going back in time, and do t of n equals 29 minus 5n. Again, the thinking here is if I plug in 1, I want to be able to get 24. That's the thinking. You need the first term to be 24. So 29 minus 5 is 24. So that's why you need the n minus 1, or you need to go back in time one step to the 0 term. This one's interesting. This one's going up by 2.5, 2.5 each time, 2.5, 2.5. So you could write it as the first term, 7, plus the rate of change, 2.5, times n minus 1. Or you could write it, let's go back in time. Let's subtract 2.5. 7 minus 2.5 would be 4.5, I think. Hang on. 7 minus 2.5. Yeah, 4.5. So you would have 4.5 plus 2.5n. Either of these is acceptable for the answer there, for that one. It's up to you which one you want to use. Let's go to the next page here. We'll do a little couple of the review problems we're looking at. Here we have 568. Great Amusement Parks has been raising its ticket prices every year, as shown in the table below. Describe how the ticket prices are growing. Well, they're not growing by a constant rate. You can tell that right away, because plus 5 does not work down the line. However, if I make calculator cam pretty big here, if we try dividing, I think there might be a constant division. 55 divided by 50 is 1.1, and 50 divided by 55 is also 1.1, and 55 divided by 50 is also 1.1. So we are multiplying 1.1 in each step here. We're multiplying by 1.1. As far as the price of admission in year 6, well, we know that year 3 is 66.5. So let's take 66.55 and let's multiply by 1.1. And let's multiply by 1.1 again. That'll take us to year 5. Multiply by 1.1 again, and that'll take us to year 6. So multiply by 1.1 3 more times. You could write this as 66.55 times 1.1 to the 3rd power. That would be another way to think about this, which is going to be $88.58, if I'm rounding correctly. In the next question, we got a system of equations to solve, so let's do that. I notice right away that we have b and b right there, so we can subtract everything right now and get it to all cancel out pretty nicely. 1239 minus 810 is going to be 429. And then 94 minus 61 is going to be 33m. So I'm just doing the subtraction there. And then the b's will cancel out. That's kind of the key there. All we got to do here is divide by 33, and that will tell us what m is going to be. 429 divided by 33 is going to be 13. So 13 is m, and that's the first part of the problem. We now need to figure out what b is. So you can choose either one of these. Let's choose the bottom one because it's got smaller numbers. We'll do 810 equals 61 times m plus b, like that. So all we got to do here is multiply 61 times 13, and that gives us 793 plus b. Don't let these big numbers scare you, man. They are just numbers that are big. They behave according to the exact same rules as other numbers. 810 minus 793 is 17. See, there you go. You could even check it. Let's check the top equation. What's 94 times 13 plus 17? Should be 1293. Look at that. Or 1239. There you go. Let's check one more. I'll do 570. Write a system of equations and solve it for the problem below. The French club sold rose bouquets and chocolate hearts. Let's use R and C. Rose bouquets, chocolate hearts. We'll use R and C for those. The roses sold for $5 and the hearts sold for $3. So 5R plus 3C is going to equal a total of 339. So that's the money equation. This is how much money they made here, 339. The number of bouquets sold was 15 more than the number of hearts sold. So I know that the number of bouquets was 15 more than the number of chocolate hearts sold, C. So there's your system of equations. This is going to be a substitution system since we know that R is equal to 15 plus C. So let's go ahead and get to work. We have 5 times 15 plus C plus 3C equals 339, like that. We're going to multiply by those numbers. We're going to distribute this 5 here. We'll get 75 plus 5C plus 3C equals 339. We're going to get 8C when we combine our 5 and 3 together. We'll subtract the 75 from both sides. We'll get 8C equals 339 minus 75. We'll get 264. And if we divide by 8 now, we'll get our final answer. 264 divided by 8 is 33. There you go. Now that's the number of chocolate hearts, and now we know that, we can go back up here and add 15 to it to get the number of rose bouquets, 48. There you go. 33 chocolate hearts and 48 rose bouquets. I hope this video was helpful to you. Hope you're staying healthy. I'm clearly a little under the weather here, so I'm a little stuffy. Is it allergies? Who knows? I'll see you in the next video. You're awesome. Don't forget that.